Hi guys, so welcome to this session, and in this session we are solving one of the modulus questions, and I hope the quality and everything is fine. Okay. Also, the audio recording and all, a little bit of experimentation is still going on. So just tell me, if you guys like it or not. So yeah, so let's go to the question. Yeah, so this is a question, and let me take the pen. Yeah. Now, guys, please pay attention. This is a standard question, okay? So this is one of those questions which you can actually expect to be there in your entrance exams as well. In terms of the level of difficulty, I would say this is moderately difficult. Okay, it's not very easy. Also, it depends whether a student knows the properties of a modulus function. So there is something called as a modulus function. Okay, so this these two bars represent an operator, which is that modulus operator. So you can imagine this as sort of a machine. Okay, so this is the machine, you can say. So this is that modulus machine. Basically, you if there is a quantity, or let's say if there is a variable, an integer, which can be a positive integer or a negative integer. So the same. So when if you put a positive integer in this machine, the resultant will be a positive integer. If you send a negative integer into this machine, the resultant will again be a positive integer. So whatever be the operation, or rather whatever be the input for the operation, the output will always be a positive variable. Now the idea is, I think most of you guys have already seen something like this. Okay, so you guys have seen the square function, right? So no matter if the square function, if you're squaring a negative one or a positive one, so the value will always come out to be a positive quantity, which is, so I can say this modulus function is somewhere equivalent to the square function, in which, let's say, if you try to square -1, eventually you'll get +1. If you square a -2, the value will be a +4, and this is not going in no uh, it is impossible to get a -4 by squaring a negative quantity. Okay, so if you square a negative x, this can never be negative y. So this is what I need you to understand. Okay, so anyways, so this is what it is. Now let's say how to proceed with this question. This question is pretty intuitive in its own structure. You see, just now as I have mentioned that the input of this, so this mod of x, the input can be a positive x, or it can be a negative x. Because this is a variable, this is also a variable, I don't know the input, whether it is a positive one or a negative one. So the idea is that I'm trying to remove the operator from the variables, and the moment I remove the operators, I will get the equation of a straight line. So let's say there will be conditions. So in one condition, this is positive, this is positive, this is one case, this is one case. The second case is this is negative, this is negative. The third case can be this is positive, this is negative, and the fourth case is this is negative, this is positive. So these are only these four cases which are possible for these two uh, operations. Okay, so let's say I take the first case and the second case. Okay, and the rest two cases will follow from the symmetry. So let's say I'm taking the positive cases. So x plus y, and I'm removing the operator, plus x minus y is equal to 10. So I straight away see that this implies that 2x is equal to 10, or this implies that x is equal to 5, right? Similarly, I'm taking now the second case. Okay, so the second case will be x plus y. Now remember, there will be a negative sign, plus again the negative part will come out, which is A negative, you can also try to write it like this: x minus y. Okay, if you are somebody who has some sort of a problem with mathematics, so you can do it like that. So this will be minus x minus y minus x, and remember this is negative of negative, so this will become positive. Okay, is equal to 10. So you will see that y and y cancel, so minus 2x is equal to 10, or this implies that x is equal to minus 5. Now please remember, this is a pretty symmetric function, or you can say, so this function, I can also say this is a function. So this function is pretty symmetric. So you will realize that initially the y's get cancelled. Now in this condition, when I am, for these two conditions, it's pretty obvious that the this time the x's will get cancelled. Yeah, so let me change the color and try to let me just change the color. So let's say, so similarly you will get a y is equal to 5 and a y is equal to negative 5. Now these are the four lines that I am getting. If I can plot all these lines, my answer will be visible. So I'm just saying that, let's say I'm taking the Cartesian coordinates like this. Okay, this is 0 0. Now please tell me, what is x is equal to 5 ka line? So x is equal to a. I hope you guys remember this thing. Okay, so x is equal to a is a line which is parallel to the y-axis, which means that x is equal to a, x is equal to 5 will be a line which is parallel to the y-axis. So let's say 1 2 3 4 5. So let's say something like this, and x is equal to minus 5 will be a line parallel to the y-axis. Yeah, so 1 2 3 4 5. Okay. And similarly y is equal to 5, so y is equal to 5, so 1 2 3 4 5. So this, something like this. Okay, I'm just making this intuitively. And y is equal to minus 5, so y is equal to minus 5. Y is equal to minus 5 will be a line parallel to the x-axis. So 1 2 3 4 5. So intuitively, now this figure over there, you already know that this is plus 5, this is minus 5, this is also plus 5, this is minus 5. Effectively this is a square. Okay, so effectively this is a square, and the square, the side length of which is 10 centimeter. Okay, so I really don't need to tell you the area of that figure, the side length of which is 10 centimeters, so which is but obvious 100. So this is it for this video. I hope you enjoyed, and this is a very simple question. This is again a CL17 question. PDF is shared in the group. Go back to the group, see if you can solve those questions, and yeah, come back to the analysis. Fine, thank you very much.